Alright, hi everyone. We continue with part 2 of the sample questions for S1 to help in our preparation for the January 2025 exams and Excel. Then is designing shelves for a bookshop. The height, each centimeters of books is modeled by the normal distribution with mean 25.1 centimeters and standard deviation 5.5 centimeters. We have question A. Show that the probability that H is greater than 30.8 equals to 0.15. We know the mean is mu equals to 25.1 and we know sigma, the standard deviation, is 5.5. So let's discuss how we are supposed to do question A. We already know that H has a normal distribution with a mean of 25.1 and a variance of 5.5 squared, 5.5 squared. So the probability that H is greater than 30.8 is equivalent to the probability that Z is greater than 30.8 minus the mean defined by the standard deviation 5.5. We have to remember the formula for calculating the Z value. Z equals to X minus mu defined by sigma. So our Z value is going to be 1.03636. So we can get the probability that Z is greater than 1.03636. So for us to get the probability, we need to remember how to illustrate this on a normal curve. So we know that the total probability under the normal curve is supposed to be equals to 1. And in the standard normal distribution table, we'll be able to get the probability for Z less than the 1.03636 that we got. So once we get the probability for Z being less than 1.03636, which is 0.8508, we'll be able to subtract the value from 1 and get the probability, this one that is shaded in green part, the probability for Z greater than 1.03636. So from the standard normal table, the phi of Z is supposed to be, the phi of a Z value of 1.03636 is supposed to be 0.8508. This is here with my pink color. This illustrated here from the standard normal table. So we can get the probability that Z is greater than 1.03636 since we know the probability for less than. So we have 1 minus 0.8508, which is going to give us 0.1492, and approximately that is just equivalent to 0.15 as required. So we move on to the other part of the question. For us to be able to answer part B, let's say Xiang decided that the smallest 5% of books and books taller than 30.8 centimeters, 30.8, this that we found in A, would not be placed on the shelves. Let's read that statement again. Xiang decided that the smallest 5%, that is lower 5% of the books and books taller than 30.8 centimeters would not be placed on the shelves. All the other books will be placed on the shelves. Nice. So the question B is, find the range of heights of books that will be placed on the shelves. What does this actually mean? We have a total probability of 1. 5% and 0.15 probabilities are not going to be included. The other part that is going to be included, which is a probability of, if we add this 0.15 plus 0.05, which is going to give us 0.2, it means 1 minus 0.2, which is equals to, if we just have 1 minus 0.2, which is 0.8. We want to know which is this proportions of 80%. What values of Z does it represent? That's why we are being asked for the range. So if we were to represent this one even here, we would say that we have the lower 5% and the upper 0.15, yeah, and this is the lower 5%. So we don't need anything here. And what we need is the green part. That's what we need. So we want to know, how do we get this range? What is the Z value here and what is the Z value here? We already know the Z value here and we know the X value or the H value, which is 30.8. So the upper boundary of the range we know, so we are looking for the lower boundary of the range. Such a good question. So move on. Let's see. So part B, like we have already explained, so it's just now going through it. Smallest 5%, that is a probability of 0.05, which we have illustrated here with the green color here on the curve. We already know that the Z value of 0.05 is negative 1.6449. So when we know the Z value, we can get the X value, or how many centimeters. So X, the probability that H is less than B centimeters, where B is just an unknown that we have chosen to use, we will be able to illustrate the expression for the Z value, having B minus 25.1 defined by 5.5 should be equals to negative 1.6449. Like we said, the Z value of the 0.05 is negative 1.6449. So cross multiply, make B the subject of the formula. So we have 5.5 times negative 1.6449, get that answer, then plus 25.1 on both sides of the equation. So we get the B value. So our B value is going to be 16.053. And therefore, the range is going to be from 16, approximately 16 to 30.8, or we can just say 16.053 centimeters to 30.8. Remember, we knew the taller percentage was 0.15 or 15%. And those were the books taller than 30.8. So we know the maximum height that we are reaching is 30.8, and the lower one we are reaching is 16.03, because up to there, anything below that is the lower. Anything with a height below 16.053 is the lower 5% of the books. So that's the range. Nice, done. Okay, so we move to the other part of the question very fast. The books that will be placed on the shelves have height classified as small, medium, or large. The number of small, medium, or large books are in the ratio of 2:3:3. The number of the books, small, medium, or and large, are in the ratio. So these 2:3:3 is the number. The medium books have a height have height x centimeters, and this x can go up to d and up to m. So m is less than x, which is less than d. What's the question? Show that d is equals to 25.8 to 1 decimal place. What's this d centimeters? So 25.8 centimeters, considering that it is the height. X can go all the way up to 25.8, and we don't know the value of m, which we'll calculate in Roman 3. All right, having the ratio and the range at which the height of the medium books can be, we can work out the value of d. So we come down here and work out the value of d. So you have small to medium to large books are in the ratio of 2:3:3. All right, so the probability that the height is less than d, where d is the maximum level that a medium book can go in terms of height, we are going to include the probability of the lower 5%, which was 0.05, the probability of the lowest value, the probability of the small, 0.2. Probability of the small is easy to find since we know the ratio of the small, medium, and large books in terms of the amount of books. And we know that the total probability was equals to 1. when we minus the lower percentage and the upper percentage of the books that are not going to be on the shelves, we are left with what will be on the shelves. And since we know the number of books that will be on the shelves and their classment is small, I will just take 2 out of the total 3 plus 3 plus 2, which is 8, of that proportion, then I'll get the exact proportion of the small. So when I add 0.05 plus 0.2 plus 0.3, which is calculated the same way on uh, right, that is on the right, on my right, so on your left side here. So we're going to have a 0.05, 0.2, 0.3, and that gives us 0.55. 0.55 is going to give us a Z value of 0.13. What does that mean? That up to a Z value of 0.13, that is the proportion of both up to medium books and the lower 5%, all included. So up to that Z value, we can calculate the D value, because we are going to make the equation for the Z value. Remember, Z is equal to X minus mu over sigma, wherever the random variable is X. And now we are using our notation for random variable to be D. So it's going to be D representing the distance minus the mean, which is 25.1 divided by 5.5, equates to the Z value, which is 0.13. So we make D the subject of the formula. We have shown that D is equal to 25.5 centimeters. Nice. Yeah. Okay. So we have part C, Roman 2, the value of M. So we need to remember we have M less than X less than D. That is the range of height which the medium books can take. And we know the probability of the lower 5% was 0.05. 5% is just equivalent to 0.05. And up to 0.2. 0.2 is the proportion of the small book. Since we know that the ratio of small books, small to medium to large, was supposed to be 2 is to 3 is to 3. So the proportion of small is 0.2 from what we. So the probability that H is less than M is equals to 0.05 plus 0.2, which is equals to 0.25. The Z value of 0.25 is negative 0.67. So we can have the expression again for Z value, which is M minus 25.1, the mean defined by the standard deviation or sigma, which is 5.5. We get negative 0.67, since we already do our Z value here, which is negative 0.67, considering that there's a probability for H less than M, which is 0.25. So the Z value is already a negative value. It's a value that is even smaller than 0.5. So in the normal curve, the value is already smaller than 0.5, and the inequality tells us it's on the left side. So that's why the negative value of Z is indicated as negative 0.67. All right, so M, we make M the subject of the formula. We have negative 0.67. We multiply by 5.5. Then we add 25.1 on both sides of the equation, and we get M as 21.4 centimeters. Nice. We move to the last part of our question. The last part of our question is here with us. Then once 2 shelves for small books, 3 shelves for medium books, 3 shelves for large books. These shelves will be placed one above another and made of wood of wood that is 1 centimeter thick. Sorry for that. So work out the minimum total height needed. The minimum total height needed. Let me remind someone something here. Three shapes, each of which thickness of the 1 centimeters, mean the thickness is going to be 3 centimeters for that. Three shapes, each of which thickness 1 centimeter, another 3 centimeters for that. Two shapes, 2 centimeters for that. And that means the total thickness of these shapes without including the other part of the box is going to already be 8 centimeters. So as we get the as we get the as we get the thickness, we should remember, or the minimum total height, we should remember to consider the height of the thickness that is going to be as a result of the shapes themselves. So that is it. So let me move it a bit. All right, sorry for that. Okay, so we move down and work out the parts. Let's see how we are supposed to do that. Here we have the height as a result of the small books, and they were in the ratio of 2:3:3. So when you multiply the height of the small books times their proportion of 2, we have 21.4 times 2 plus, as a result of the medium books, the maximum height would be 25.8. We calculated that as the value of D previously. So 3 times 25.8. Then for as a result of the large books, 30.8, that was the maximum height, because any height above 30.8 was not supposed to be placed on the shelf. So 30.8 multiplied by 3 plus the height that is just calculated here, the 8 centimeters to for the for the thickness, this part, for the total thickness of those shapes, 8. All right, so that is where we are getting the 8 centimeters, and we're supposed to add to those other centimeters that we are already aware where we are getting them. And when we add that, we get 220.6 centimeters, which is approximately equivalent to 221 centimeters. Nice. And done. We move to the next question. The Venn diagram shows the events A, B, and C and the associated probabilities. Venn diagram, much likely to be there in the exam, with the probability in A being equals to 0.15 plus 0.2. Probability in B is 0.2 plus 0.17 plus 0.23. Probability in C is going to be 0.23 plus 0.12, and probability of an event being outside A, B, and C is 0.13. So we are trying to find the probability for B complement or outside B, probability for an element being in E union C, and probability of A given B complement. So let's see. The probability for B complement is simply this. Let me show you. The probability for B complement is simply anything outside this circle for B complement. Anything outside this circle for B. That is that, and that. 0.15 plus 0.13 plus 0.129. If we can see, that is what we've done. 0.15 plus 0.12 plus 0.13. Nice. So that is how that is supposed to be. The other one, so we have probability of A union C. A union C, everything in A unite with everything in C. So everything inside A here, that is 0.15 and 0.2 unite with everything in C. 0.23, 0.12. Did we do that? Yes. 0.15 plus 0.2 plus 0.23 plus 0.12, we get 0.7. Done. Part C. The probability of A given that B complement. What does this mean? An event in A given that it is outside B. So we can apply formula. We can apply probability formula to make it look even nice. The probability of A given not B, probability of A given B complement is the probability of A intersection B complement divided by B complement probability. So the probability of outside B, we already calculated it, but we have calculated it again, 0.15, 0.13, 0.12, which is 0.4. That is outside B. A probability of A intersection B complement means in A and outside B. Wow! In A and outside B. Let's see. These elements should be in A and outside C. Who can see what I can see? Wow, nice. In A, outside B. This one, 0.15. Nice one. So what do we do after that? We simply divide using the probability formula. So 0.15 divided by 0.4, and we're gonna get 3 out of 8. Good. And done. Thank you so much. Wait for the next part of sample question in the next video. See you later.